Good morning. I welcome everyone to today's presentation, and I thank the people at Maplesoft for giving me this opportunity to present today. So today I'm going to talk about a cleaner way to change roles using the new Lap-Less Splice Unwind. So splicing of the leading edge of a new roll of material to the end of the expiring roll is a consideration on every web processing line. For each process, you need to consider what splicing method is most suitable for the web material and what splicing method is most suitable for the process. So for those processes where a tape splice can be used and an automatically formed splice is preferred, Nuera's patented Lap-Less Splice Unwind, also known as the LLS Unwind, offers many advantages over other traditional methods. So this patented unwind provides an automatic splice that does not have an overlap of the web, does not have a free tail, and is formed without the need to stop or slow the web. The unit is designed to operate at speeds of up to 1,000 feet per minute. So let's talk about a traditional flying splice unwind and how the splice is actually formed. So traditional automatic flying splice unwinds provide a lap splice with a piece of double-sided tape being sandwiched between two layers of web. So here you see a sketch or drawing that shows what that splice looks like. So the bottom red line, which is moving toward the right, is the end of the expiring web, and the top red line represents the leading edge of the new web. The green segment in between is the tape that holds the two pieces together. So this splice, or this type of splice, can result in several issues, including the need to open nips as the double thickness of web passes through the process. So this is particularly true in the areas of the coder. So maybe you have multiple rolls on your coder where the splice can't pass through, or maybe there's a gap between a die and a roll, or a knife over a roll or plate where that double thickness of web can't pass through. So as a result, you need to open up the rolls or the die or the knife blade to allow the splice to pass through, which causes an interruption in your coding process. Additionally, there's the inability to control the tail of the web. And by tail, we mean that length of web on the expiring web material, which is from the splice tape to the end of, or the cut that's made by the automatic cutting mechanism. So this uncontrolled tail is free to flap around through the process. And as a result of both the double layer of web as well as this uncontrolled tail, when you wind the product, multiple layers of web in the product roll can be damaged by the thickness of the double layer of web, as well as that uncontrolled tail being, folded over or balled up in that product roll. So let's talk about butt splice unwinds, because there are many systems provided featuring an unwind designed to provide a butt splice with the end of the expiring roll material being butted up against the leading edge of the new roll's web. So here you see again a sketch or drawing depicting, in this case, a butt splice. So on the right side, as the web moves from left to right, is the end of the expiring web, and butted up against that is the leading edge of the new web, and tape is placed typically on both the top and bottom sides of that. So this type of splice eliminates both the double thickness of web and the uncontrolled tail. However, traditionally, both ends of the web needs to be stationary in order to perform the butt splice. Therefore, in a continuous operation, so where you have a machine where you want to run the process continuously while you form the butt splice, machine sections are required to allow for the feed of the web to the process while the unwind is stopped. And these machine sections typically take one of several forms, including, so on the left-hand side, you see an accumulator where you have a machine section with a series of rolls, some of which are fixed and some of which move in a carriage. And that carriage can move up and down or can move horizontally. And the web is laced amongst those rolls. And so prior to a splice being formed, the carriage moves away from the fixed rolls, which stores a portion of web inside the accumulator. So when the unwind is stopped, the process continues to be fed by the web that's inside that accumulator. So the rolls move toward each other with the web continuing to be paid out to the process while the web at the unwind is stopped for the butt splice to be formed. Or you can use a J-box like shown on the right-hand side. So in this case, excess web is fed into the J area where it is held for the time while the splice is being made. So when you're going to make the splice, the unwind is stopped and the web material continues to be paid to the process from that web that's stored in the J box. So the addition of these sections can present several process-related issues, including taking up significant floor space, requiring a significant number of rolls to contact the web, which can create scratches, can induce static in your web, and can cause stretching of the web material. Additionally, the addition of these sections don't really lend themselves well to high-speed operations where a significant storage time is required. So it may not be practical to have an accumulator or J-box that allows for the storage of the web that might be required for high-speed operations. So Nuera's LLS Unwind or Lap-Less Splice Unwind addresses the issues associated with the previously described unwind systems. It allows for the formation of a splice that has no overlap of the web, has no free tail, has no exposed adhesive side of the tape, and is performed without slowing down the web or slowing down the unwind to allow for the splice to be formed. So let's talk about how this LLS Unwind works. So it's based on the use of a traditional flying splice turret unwind, like you see here. So this flying splice turret unwind includes a turret portion for supporting the incoming rolls of web. So as you see here, this turret happens to be a 2-spindle turret. So the inboard spindles, or those more toward the left, would hold the running web of material. So this roll is feeding the process, while the outer spindles shown on the right is used to put the new roll of web material in and have that prepared for splicing. Also included in the turret unwind is a splice assembly like you see here, which is complete with the bump roll and cut-off knife systems that are required to make the automatic transfer of the the expiring web, really the end of the expiring web, to the leading edge of the new roll. So added to this splice assembly is a specially designed a splice roll system, which is located, as you see here, at the exit end of the splice section. So this splice roll assembly includes a backing roll, about which the web travels, and which is typically rubber covered, as well as a splice roll, which is either a vacuum roll or a chrome covered steel roll, and which is servo driven. So you see the gray roll in the foreground of the picture. That happens to be, in this case, a vacuum roll, which is the vacuum roll of the splice assembly. So also included or added to your typical turret unwind are the required drives, controls, and programming to allow the LLS system to function properly. So let's talk about the steps required to prepare and form the splice. So while the web is being delivered to the process from the turret's unwind, one of the unwind positions, so as we showed in the previous photo, the inboard spindle, the operator loads a new roll of web into the turret unwind's other position. The operator then prepares the leading edge of the new roll. So in a traditional turret unwind, or a traditional splice being formed by a turret unwind, an operator would take a double side tape and place it on top of the leading edge of the new roll of material. In the LLS unwind, the major difference in how the splice is prepared is the operator puts a single-sided piece of tape under the leading edge with a portion of the tape, or the portion of the splice tape exposed for splicing. So as you see here. The operator also prepares the splicer roll by placing a strip of tape, and again single-sided tape with the adhesive side out, on the splice roll in the designated area. So as the running roll of web approaches minimum diameter, the new roll of web is indexed into the splice position and is accelerated so that the surface speed matches that of the running web. When the running roll reaches minimum diameter, the bump roll and knife are fired in sequence, cutting the web so that the end of it lands on the exposed tape located on the new roll surface. So let's see how that actually looks. So this newly formed splice exits the new roll of web and travels to the splicer nip, as you see here. And the splicer roll, which has already been accelerated so its surface speed matches that of the web, and has been positioned so that the tape is in the proper orientation with the incoming splice, is nipped to the backing roll. And as the newly formed splice passes through the nip, the tape from the splicer roll is applied over the exposed ends of the web, and the splice exits the splice nip assembly as the splicer roll is retracted. So let's see how this looks. So the previous example showed the LLS unwind using a traditional rupture style knife. Now for certain applications, the rupture style knife may not work. You know, there's some materials that just can't be cut with the rupture style knife. So in those cases, the LLS unwind can be provided with a shear knife, which typically cuts most materials. So in summary, the LLS unwind works with any web that can be cut with a rupture or shear knife, works with any material that can be spliced using pressure-sensitive tapes, provides a fully automatic splice with no web overlap, no free tail, and no exposed adhesive, Has a maximum operating speed of up to 1,000 feet a minute, with the maximum speed dependent on several factors, including what the materials are, what the web width is, what the diameter of the unwind rolls are, and can be tested on Nuera's unwind winder test stand using customer supplied materials at speeds up to 1,000 feet per minute and widths up to 80 inches. So I thank everyone for attending, and I hope you found this information to be informative.
Thank you, Bob. Thank you for explaining your process. That's quite an achievement to develop that over your production team, and having such good range as well. The 1,000 feet per minute. That's not like just experimental. This is fully ready for prime time, and I'm sure you have quite a few happy customers out of that one. For those who are on the audience, if you have any questions about how this works and wanted to pick Bob's brains, please type your questions into the chat and we'll ask them on air. Bob, how long was your team developing this? Because this is something that it must have maybe come out of a project or research for your hardware teams. How did it kick off?
Yeah, we had first of all, thank you for having me here, and thank you for the question, whoever asked it. So from concept, and the concept started from something internal where we recognized a need in the industry for it. It didn't come from a customer specification or a customer requirement per se. Uh, so from the concept to when we were ready to release it for marketing type purposes as well as to apply for a patent, took somewhere from about 9 months to a year. The patent process takes sometimes multiple years. I think in this case it was closer to 2 years to actually get the patent approved. But once we did a patent search and we could, we were reasonably certain that it was a patentable product, we could then go ahead with the patent pending nomenclature, and then follow that up obviously with the patented nomenclature.
Right, and that's certainly a lot of the admin behind the scenes when you're coming up with new innovation. It's protecting your rights, but also allowing it to be launched to market and explained to possible new users that you didn't imagine at the time. Has there been pickup in certain markets or segments that you didn't expect when you were first bringing it to market?
Yeah, we first brought it to market. We had certain industry sectors that we thought it was, going to potentially be something beneficial. We thought, printing area, which we don't do much work in, but we thought that the printing area is one area where it may be. We're still waiting or seeing that market develop. But there's been some other interesting markets that it's shown to be useful, like the membrane industry, for example. We've sold some equipment into that area, which we didn't foresee that as a possible use of it. So, and we've gone through, based on some of the market requirements, we've gone through several generations of it. We're kind of on our third generation right now, making, modifications and adjustments to it as we see needs and demands changing, and as we get feedback from the customer base who's using it.
Certainly, yeah. And in terms of when often we go to some of the trade shows and expos, you see a lot of different solutions that are trying to work around this challenge, like robotic arms that transfer things between different lines, different splicing techniques that slow things down or buffer them ahead of the process. So certainly this has brought to light a new way, a new approach that kind of can even save space on the factory floor if you're looking at it with a new technique. Yeah.
Yeah, and safe floor space, as we said, gives certain other advantages, such as if you're going to do a zero speed splice, let's say, to get the butt splice, then you have to introduce a series of rolls, potentially if you're using an accumulator or a J box section where you're dumping material in. So this has the advantage of not needing those types of sections.
Great. Well, thank you, Bob, for the time today and for explaining your process. I really appreciate the effort you have and just demonstrating some of the videos as well. Really brought it to life with how it could be applied in different circumstances. Thank you again for your time today.
And thank you, Alex. Have a good day, everyone.